This is the AVR of 2000 kVA alternator. The type of AVR is R449. This is the nameplate of the alternator, and this is the AVR. These are the loop city connections. These are the biasing from sync controller, plus minus 1 or plus minus 3 volt, and these are the winding connection X2, X1, X1, Z2, E plus, E minus. These are the auxiliary winding X1, X2, Z1, Z2, E plus, E minus goes to exciter, stator, and these are the wire V and W and V from main stator. These are from the main stator, 415 volt AC. These are the DC output. These are the input UV. These are the DC output, and these are the auxiliary winding to get supply for AVR to activate. And these are the S1, S2 wire from loop setting for reactive power sharing, and these are the biasing for voltage regulation from sync controller. These are the RTD BTD to check the temperature of the bearings. The 24 core wire, and this goes to sync controller temperature scanner. These are the rotor temperature detectors, and these are the bearing temperature detectors, RTD and BTD. And these are the another non-driving end, RTD. And this is the capacitor connection, 230 volt AC. Capacitor is required to for heating of the alternator in case of moisture content. That moisture minimize the insulation resistance value. At least 10 mega ohm should be the minimum value as per the IS standards. Below that, it will be risky to run the alternator. So capacitor is very important to give the supply to heaters, which heat up and reduce the moisture and dust particle and moisture and water particle inside the winding, and save the alternator from getting earth or weak in case of weak insulation. So this is the AVR R449, and it's working. This is the diagram. This is the output E plus, E minus, X1, X2, Z1, Z2 or the auxiliary winding to activate the AVR. The output DC to exciter, stator, and these are the input from main stator. These are the relay. This is the in short AVR details and the information of the AVR, and this is the nameplate of the alternator.